Motor Racing USA. An arena in which the difference between winning and losing is less than a heartbeat. In 1969, the first IMSA race attracted a modest audience of less than 400. Today, over 400 million around the world witness the contest on the track. But the real competition lies behind the glamour, in the minds of the designers and engineers who create the most powerful race cars in the world. Working at the frontiers of technology, restrained by the rule makers, motivated by the thrill of competition, each team strives to find the leading edge.
It's always a combination, and that's what a car is, a combination between the chassis, the engine, transmission, driver, team. Only a good combination can win.
And racing does have a tendency to make people do things a lot quicker, because there's a timetable, and you got to I mean, there's races you got to go to, and there's competitors you got to try and beat, and so it forces you into a sort of a high-speed development mode.
The GT series cars are capable of speeds in excess of 200 miles an hour. Powered by engines which can produce over 1,000 horsepower, these are not engines specially designed for pure racing. They're based on production car engines, which in their showroom form produce perhaps only a fifth of the power.
I think we offer a lot more. I think our cars are, first of all, they're identifiable in the sense they carry the characteristics that people deal with every day in their street car. They have headlights, they have tail lights, they have brake lights, they run in the rain, the doors open, they have windshield wipers, they have to race in all kinds of conditions for all kinds of lengths at speedway tracks, at airport tracks, at temporary tracks, at permanent tracks, and they're powered by an infinite variety of power plants. There's an infinite variety of car design. And it's basically a concept to allow creativity and freedom in design, while everything else is more structured. And I think it's almost the last form of motorsport in the world that gives the innovator the opportunity to innovate.
Rule makers IMSA, the International Motorsports Association, has been very successful in the USA in creating a balance between different engine technologies. They enforce a system of technical handicaps which offset certain design advantages. The aim is to provide the teams with the maximum design flexibility and the audience with good spectator sport.
The concept, particularly in GTP, which are the purpose-built racing cars, and the GTO and GTU cars being production-based versions of the same, the whole idea from the start was to provide formulas that, again, were attractive to as many possible interests.
Within the rules set by IMSA, team designers are free to experiment with many different engine configurations. The manufacturers behind the teams offer the full range of production car engines. So just as in the showroom we find V6, V8, V12, flat 6, straight 4, and a range of add-on performance improvers, turbochargers, sophisticated fuel injection systems, multi-valve heads, each combination has its own special characteristics. Having the right combination gives the advantage.
Well, I don't know whether it gives us an edge, but at least it gives us a means to adjust the things, you know, the way like we want to do it without going over Germany, because it takes a lot of time and a lot of money.
There are tremendous research facilities that the big car companies have. We can't really match, but on the other hand, we can move quicker than their internal organizations can in a lot of areas to bring something to bear to test.
Yeah.
And it'll take them sometimes 5 years to bring new technology into production, just because there are super long lead times and tooling and everything. Or what may take them 2 years to set up production for, I can do in a week around here.
Yeah.
And so we can move quicker,
yeah,
and we can take advantage faster of new technology.
But like Ford, Lincoln, Mercury says to us, their engineers are used to doing things on a year, you know, on a really long extended schedule. There isn't that sort of impetus to drive them faster and develop things quicker. And those guys come to the race team and work with us for a year on that fuel management system, and they go back and they have a whole new sense of how much quicker things can be done sometimes if you really need to do it.
Previously, I've worked with an automotive company, one of the big three, and from the time that we clay modeled something till it got on the road was 5 years, 3 to 5 years. To see it done in 3 to 5 months is very satisfying.
There is a significant interchange of ideas and technologies between the big manufacturers and the racing teams, but not in the direction their relative sizes might lead you to expect.
We have several parts that we've developed for the Merkur engine that are now being prototyped and fit to new prototype Ford Motor Company engines as well as Chrysler engines. There are several other things that we're doing in the area of the carbon fiber bodywork for our race cars that we're exploring the possibility of trading that back into production car technology to build lighter, more aerodynamic production cars. Certainly the aerodynamic work we do in the wind tunnel for our race cars is already seeing its effect in the production car technology.
The large manufacturers recognize the effectiveness of small, dedicated teams, being prepared to adopt a hands-off policy. Nissan team manager Don Devendorf sees this from the perspective of the aerospace industry.
I'm a chief scientist at Hughes Aircraft, and a lot of the technology programs, most of that work is carried on by a very small group of people that do a lot of these advanced concepts and make some of the first prototypes and prove the feasibility of various concepts. And it's really amazing if you have a very, very talented small group, what that can accomplish relative to, you know, a huge group with tremendous resources. And very often, you know, the managing of that huge resource is such a problem. It's very difficult to be efficient. And very often these things can spend, you know, 5-10 times as much and not even achieve, you know, what the smaller group has done. And that's common, I would say, throughout any kind of the normal industries. And so, you know, if you apply the right people with the right philosophies, have a positive attitude about, you know, solving problems, and you know, you always find a way. You know, if you start off and say that can't be done, you know, you know, they'll never accomplish it.
Each team has its own approach to obtain what they see to be the right combination of engine, aerodynamics, and handling. Hopefully the winning car.
You have to consider the whole car, not just the engine, not just the support systems, not just the charge system or the turbocharger. It's a complete package that you have to consider. Drivability is a huge part of the program, probably even more important than absolute horsepower. The catchword you see in all the television telecasts is turbo power, and how it's bowling over the normally aspirated cars.
Again, you see some of those Camel light cars just being overrun by these tremendously powerful prototypes.
Little step on the brakes. Now he'll be back under full boost and trying to use all of the Porsche horsepower. Look at this. Closing, closing, closing. Here comes the pass. Down the inside, use that late braking to get a clean pass.
And gets past the number 52, that Corvette. Last lap at 114 miles per hour by the leaders. He's up on the Buick now. Look at him take a couple of shots trying to get the car through there, and finally loses it to go to the outside and let it through.
For a number of years, Porsche have dominated GT motor racing in the USA, but others now seem to have a better combination.
What we're trying to do is like, how can I give an example? If you have some running shoes and they're 2 numbers too small, and we try to, you know, widen them out with some devices. What we need is a new shoe. And that is, you know, like as long as we had no real competition, it wasn't really shown, but as soon as Jaguar showed up, their chassis is far superior. And of course the Nissan, their chassis is good too.
Look at how many moving parts there are in a typical automotive engine. I mean, if you didn't have an automotive engine out there running and you thought to yourself, well, geez, now I could build something like this, it's going to have It's going to have pistons going up and down at this rate of speed, and it's going to have a crankshaft spinning. You're going to have a controlled oil system. You got to seal the compression system between the oiling system with sliding rings. I mean, you couldn't do it if you just tried to think of it without it having been done over the years. But so I think it's a matter of just development, and a turbocharger is a much simpler system than an automotive engine. But I think that's where the turbocharger manufacturers like Garrett are. They're developing that technology right now and getting it to the point where it has the durability that you want.
Los Angeles-based Garrett Automotive supply over 50% of the world turbocharger market, and an even higher proportion of the turbochargers used in motorsport. Garrett claim the reason for their success in motorsport goes beyond the reliability and performance of their product, extending, they say, to effective applications engineering. There's no doubt that turbocharger technology has been a factor enabling smaller engines to compete and often outperform the larger and heavier rivals.
The turbo offers such an incredible advantage because you can lower your total package weight and size immensely and then make up for it with the turbo. And then because you've got low inertia of the total motor package and you've got small amount of surface area, your thermal efficiency goes up, and you can do better fuel economy wise with a small turbocharged engine than you can with a bigger engine. Your amount of oil cooling it takes and water cooling it takes is all reduced because the engine package is small.
The amount of power the engines in these cars develop is dependent on the amount of air and fuel that can be burnt in the cylinders. More power requires more air and more fuel. But the engine only has a certain cylinder capacity, and this limits the total power available. A turbocharger is a device which compresses the air-fuel mixture, and so increases the amount that can be burnt in each cylinder. This helps the engine develop more power without increasing its size. The turbocharger is a simple device with a few moving parts which takes energy normally thrown away in the engine exhaust and uses it to drive a compressor. The turbo's outer casing contains a single shaft with a wheel at one end. Hot exhaust gases from the engine pass through the casing and around this turbine wheel, causing the shaft to rotate at very high speeds, as much as 200,000 RPM. A second wheel is attached to this shaft which draws air in from the atmosphere, compresses it, and pumps it into the engine.
You know, the turbo technology has really come along, and I know just in the short time that I've been driving a turbo car, which was last year, we've made some pretty great strides, I think.
Turbocharging in both Formula One and GT racing is often blamed for engine failure, without good reason.
I would say that it's like a little excuse of the press, because they're not maybe investigated enough to find out really what happened. And if they see blow smoke, it's right away the turbo. And I can say majority it is not the turbo. Or the turbo fails, like I said before, because the engine failed before. So now, the turbo reliability these days is pretty sophisticated, pretty good.
You know, I think last year we had one engine failure, which was a broken rocker arm. And with that kind of reliability, you know, you just, the turbo technology certainly isn't hurting it at all.
Because the turbo is driven by the engine's exhaust, there can be a delay of a fraction of a second before the turbo takes full effect. This is known as turbo lag. In the latest turbo cars on sale in showrooms around the world, turbo lag has been virtually eliminated by improved design, materials, and electronic controls. Motor racing, on the other hand, suffers from turbo lag of a different kind.
The prediction today is that we would like to see more improvement on the turbocharger, and that of course can only come from the manufacturer. We cannot do that. And what I would like to see is what is already today on the market is an adjustable turbo. It adjusts itself on the exhaust side, and of course a ceramic wheel. You know, the lighter it is, the less inertia, better is a boost builder, because our biggest problem obviously is the lag. And that is where we have to work on. It takes a lot of money to develop stuff like that, to make it race ready. I'm sure maybe for passengers, they have it already. Garrett.
I mean, it'd be lovely to have no throttle lag at all. It seems, I mean, it's almost instantaneous now, but it would be nice when you back off, as I did once and with rather low revs, to have picked up and got torque lower down. A couple of times I thought, my goodness, I must be in fourth that second when I had to slow down for other traffic.
I think that the leading edge of technology as far as engines are concerned, turbocharging is concerned, and engine control systems are concerned. I think that that is definitely true. I think that the leading edge is coming towards sports car racing, as in our Merkur here. I think that you'll see more and more development going on as far as turbocharging and engine control systems, because like in our XR4 TI, we're running the exact same system that's in a Formula One car. And then from that, we will redefine it. Ford Electronics will go back and make it better and better and better. And so the leading edge of technology would be here, in turbocharged four-cylinder engine.
Explains what the IMSA series means to Jaguar.
It's a new challenge. We want this team to be like our road car owners. They're Americans who buy a Jaguar and run it in America. This is an American team running a Jaguar in America, in American racing. And there's a real strong American accent. I got an English accent because I came over here to cheer them on.
Well, perhaps by the time it's all over, we Americans will know how to properly pronounce Jaguar.
Because of the standard preparation, the way this team operates is second to none, and the car is well designed and properly engineered and properly looked after by the mechanics.
This professional approach has helped Jaguar score notable successes, including the top 3 places at the prestigious Le Mans 24-hour race. The similarity in the specifications of the Group C and IMSA series has helped Jaguar mount a formidable presence in both classes.
Well, of course, we've got 2 teams here. We've got our US IMSA team with their 2 cars and then 3 cars from here. So it's a relatively simple effort for us in that we can use both racing teams. 5 cars has to be better than 3. It is a lottery. There are all kinds of difficulties occur in this 24-hour race. It's a very punishing race, and the more cars, the better.
The IMSA GT series features a wide variety of surfaces and distances, which influences the way the driver approaches each race.
The main difference is in the method of how you get through the race. In a 1,000-kilometer race, in fact, that's a sprint event for us. We drive on the limit for 1,000 kilometers. Here at Le Mans, we obviously had the conservation of the car in mind. So I wouldn't say that we drive very far off the pace, but we certainly drive maybe 8/10 instead of 10/10.
It's just so good to be involved with a team like Jaguar, because it's not just a car, it's England is down here trying to win.
For the green flag, back underway. The Jag makes an immediate move and does not get through.
Now here's where experience is going to play a major part. Again, these fellows are back on cold tires once more. We saw, now, there's the Jag. It's a good indication of what's happening.
The Jaguar commitment is obviously a serious commitment. They're here to win, and they will do whatever they can to win, and that forces them to push themselves for success as well. For a long time, Porsche has been the dominant force because of their commitment to motorsports worldwide.
In the quest for even higher performance, the Porsche team acknowledges that in the modern racing engine, electronics are playing an increasingly important role.
Electronics are just about taking over everything. You know, we've got rent-a-cars out here that I can't believe the electronics that are on them. They're brand new cars. And they'll take over in racing just like everything else. At this minute, our fuel management system is all controlled. The ignition timing is all electronically controlled.
All Porsche racing engines are prepared in California by racing specialist Andial. Each engine is run in a test cell on a dyno, which measures its power output. This information is used in the programming of the EEPROM chips in the electronic engine management computer. Founder of Andial, German-born Alwyn Springer, explains.
So actually what we do is we go to the dyno and run some values. You know, some improvements, maybe it needs more gas, maybe it's less gas, more timing, less timing. That's basically what we do on a dyno. And our computer programs enables us to go and reprogram the EEPROM programmer and then again the EEPROM. So if I would do that by hand, if I have to change a lot of stations, it would take me maybe an hour, 2 hours, and like that it takes me 5 minutes. Advantage of the computer. So let's say we want to change the value of an injection from it has 3 parameters. Once we have the boost level, once we have the throttle opening and the RPM. So it's pretty sophisticated. So what we can do, we'll say at full throttle at 2400, we want to change something in there. So we'll go. So you see, right now it tells us this is the injection field. At 62 degrees, that is the full throttle field, 2400 millibar, because we read absolute, 8,000 RPMs. And then see it goes down every RPM. You know, when the driver drives and he feels that when it goes at 1.4 boost, it just gets a little bit tough. And we have a switch in there where you can lean it out or richen it up. And he says, you know, if I richen it up 10%, it runs better. So then we just, instead of like before in a carburetor, we will change a main jet, what would react over the whole range. That just specifically just goes in that little range there. So and if we do that here, see, I have a little calculator built in here too. So it says X number 72, percentage rate plus 10. See, and then the new number is 7D. So I just type 7D in here and go on. Then later on, when I'm finished, what I can do is I can go into a graph program. If I make somewhere a mistake in programming and I double check it this way, then I'll recognize it right away and can prevent a lot of engine problems.
Porsche's arch rival Nissan have enjoyed recent success, which could be due to new software they've developed which electronically controls the turbocharger and engine combination. A concept that is not new in racing and which has been used in production cars for some time.
They had it already last year, and obviously they got it working right. And we're a little bit behind, but we're working on one too, and hopefully that we will get it going within the next couple of months. But for us, specifically in the Porsche business, it's very difficult to catch up to the Nissan, because, you know, the basic differences between our engine, their engine is, it's like if you compare apples with pears. Now, because our engine is a flat 6-cylinder air-cooled engine, where the engine is a V6 water-cooled engine, and that's being turbocharged. The air-cooled engine it's a handicap. So I don't think that we will catch the Nissan this year, but hopefully that we can try to run with the Jaguars.
What is the cost of preparing and racing a car in the IMSA GT series? And can this cost be justified by manufacturers and sponsors?
I mean, to do a full series program and this type of thing is over $2 million a year. It's more than that.
The manufacturers typically have much better budgets when it comes down to budgets than racing. I mean, you see a lot of money being spent in racing, but relative to the manufacturers, it's not very much.
Engine-wise, the engines run about $45,000 a piece on our little V6s, and they're very similar on the V8s. But as far as the overall program, I wouldn't want to get into that.
The budgets are varied quite a bit from team to team, and some teams are able to make do with less and get good results. I think we've been, if I may brag a little bit, been pretty good at getting by with what we know to be a comparatively small budget.
The key to sponsorship is audience. So what kind of people follow GT road racing on the track?
We like to look at our audience as a quality audience. An easy way to compare it is, I think, in many cases, we're selling classical music as opposed to country and western or pops. It's not as big an audience, but the people that are here are much more tuned into the equipment, much more tuned into the people, and I think they're interested not just in the competition on the racetrack. Sometimes the racing is outstanding. Sometimes one guy has it figured out better than the rest, but the other draw is the technology and the variety that's on display here, not only on the racetrack, and the accessibility of the equipment to people. We're standing in a paddock area, and 90% of the people here are paying spectators who have an opportunity to walk up and virtually touch what they see on the racetrack, which is in other forms of motorsport in this country is impossible. They can't go at Indy or NASCAR to the garage area and see the cars. Here they can.
John Morton of California and Jeff Brabham, victorious twice in succession for Team Nissan. A great victory here at Palm Beach, Florida. Second place is going to go to the Jag. Davy Jones is home in second. Price, Cobb, and James Weaver will finish.
1988 was undoubtedly the year of the Nissan. They got everything right, all at the right time, but more importantly, they briefly found the edge, the leading edge, which for them was a superior electronic management system for the engine, and particularly the turbocharger. It won't be long before other teams catch up, or IMSA changes the rules to offset the advantages, leaving them once again in search of the leading edge.
One of those believers in, racing does in fact improve the breed. It allows you to get engine management systems, tires, chassis developments that you could not otherwise achieve.
You've got two ways to look at it. You either play the game or you get out. So as long as I feel that we can be competitive, I'll play the game. And when I feel I cannot be competitive anymore, then I will no longer build a turbo engine. I mean, it would be foolish.
I expect it to continue until such time as every different manufacturer is able to win races, whether it's a normally aspirated vehicle or a turbocharged vehicle. As long as you have a team such as ours sitting on top with good drivers, good team, and the best cars, the best preparation, the best sponsorship, the best financing, we're going to win.
Because as long as we win races, that's what it's all about. And that's what we're trying to do.